here one of the example is that find the third velocity component such that it satisfies continuity equations. Given the components of the velocity, so u is given, which is x square plus y square plus 2z square. So velocity component v is given as minus x square y minus y into z minus xy. So here we have to, because since it is a three-dimensional problem, so therefore we have to use three-dimensional continuity equation, that is dou u by dou x plus dou v by dou y plus dou w by dou z should be equal to 0. So the third component is now in the z, that is the velocity component in z direction, that is w. So now we have for continuity equation, which is given by, so dou u by dou x plus dou v by dou y plus dou w by dou z should be equal to 0. So take u, differentiate with respect to x. So differentiation of x square is 2x, so y square will be 0, 2z square will be 0. Similarly take v and differentiate with respect to y. So differentiation minus x square is a constant, differentiation of y is 1. Similarly minus z is a constant, so the differentiation of y is 1. Similarly minus x is a constant, differentiation of y is 1. So that is what written. So now substitute dou u by dou x and dou v by dou y in equation 1. So therefore we have, so like you can get the term dou w by dou z as so like minus 2x, so plus x square, so plus z plus x. So minus 2x plus x is minus x, so minus x plus x square plus z. So now we have the term dou w by dou z. You can integrate this with respect to z. So if you integrate with respect to z, we'll get, so integration, so your integration of 1, so minus x is a constant, integration of 1 is z, so you get minus xz. Again this is a constant, so you will get x square into z, and differentiation of z is z square by 2. So this is how you get the component of velocity, the third component of velocity, that is w, that satisfies continuity equation. You can take one more equation which is given as u is equal to log y square plus z square and v log x square plus z square. We have to find the third component, that is w. Again taking continuity equation, so dou u by dou x plus dou v by dou y plus dou w by dou z will be equal to 0. So therefore we have here, so if you take here differentiation of log y square plus z square is 1 by y square plus z square, so there is no x term, so it will be 0. So then taking v, so this is differentiation of log is 1 by x square plus z square, so but there is no y term, so it will be 0. So similarly they write the dou w by dou z, that will be 0. So therefore we know that dou w by dou z is 0. So if you integrate this with respect to z, so here differentiation of constant is 0, so integration of 0 is a constant, so therefore w will be equal to a constant. So when so you know that since it is a constant, so by seeing this equations, u is now log y square plus z square, v is log x square plus z square. So now that means here w has to be here again if you want to write in the cyclic order, so after that it will be here something like x square plus y square. So okay, so therefore this constant has to be log of, instead of x square you write it, next term will be y square, and instead of z square it will be x square. So therefore it will be, so w has to be in cyclic order, can be that constant is a function of x and y. Okay, so therefore it will be log of x square plus y square. So this is how you can write. If you are able to write the constants, you can write it, otherwise you put it as 0. So the next problem is that given the velocity components, so here u is y square minus x square by x square plus y square whole square, and v is given as minus 2xy x square plus y square whole square. So show that fluid is incompressible and flow is irrotational. Here to show that the fluid is incompressible, we have continuity equation. So when the so for that we have a study which is applied to the steady flow of a two-dimensional equation, so which is given by dou u by dou x plus dou v by dou v by dou y should be equal to 0. So now you take this velocity component and differentiate with respect to x. Take this component v and differentiate with respect to y and put it equal to. So suppose you get 0, and then the fluid is incompressible. So we have flow to show that flow is rotational. Here the rotational component has to be 0. So omega z should be equal to 0. So now, so here for a steady flow of an incompressible fluid, we have continuity equation. Since it is a two-dimensional problem, we have dou u by dou x plus dou v by dou y should be equal to 0. So take this equation u. Okay, now you know that it is the numerator is also a function of x, denominator is also a function of x. So therefore you have to take dou u. When you write dou u by dou x is denominator, differentiation of numerator minus numerator, differentiation of denominator by denominator square. So now taking the denominator, that is x square plus y square whole square. Okay, differentiation of numerator, so y square differentiation is 0, so minus 2x, differentiation of minus x square is minus 2x. So here minus, okay, numerator, differentiation of denominator is 2 times x square plus y square, and differentiation of x square is 2x divided by denominator square, so it is x square plus y square to the power of 4, like this. So now taking x square plus y square, so cancelling out. So here this 1 x square plus y square cancels out, this x square plus y square, and you are left with x square plus y square cube. So therefore it is x square plus y square into minus 2x. So here it is x square plus y square cancels out. So 2 into 2 is 4x. So minus 4x into y square minus x square. So simplifying this further, so we get, so like minus 2x into x square is minus 2x cube. So minus 2x into y square is minus 2x y square. Similarly minus 4xy square plus 4x cube. So this can be written as now 4x cube minus 2x cube is 2x cube minus 6xy square divided by x square plus y square whole cube. So this is about dou u by dou x. So now take equation for, so v is minus 2xy by x square plus y square whole square. We are differentiating with respect to y. So again numerator is a function of y, denominator is also a function of y. So when you write dou v by dou y, denominator minus sign you can take out. So denominator into differentiation of numerator. So minus here. So you can take a minus 2x, you can take it out. So here we have denominator into differentiation of y, that is 1, minus numerator, differentiation of denominator is 2 times x square plus y square, to differentiation of y square is 2y. So by denominator square. So this is how you can simplify by cancelling out x square plus y square. So therefore this is written like this. So now simplifying this term, it is minus 2x. Here it is x square, so plus y square, so minus 4y square is minus 3y square. So this can be written as minus 2x cube plus 6xy square. So now we have dou u by dou x and dou v by dou y. So now you're putting in the unit equation. So that can be written as like this. So now 2x cube will cancel with minus 2x cube. So minus 6xy square will cancel with plus 6xy square. So it will be 0. So hence dou u by dou x plus dou v by dou y is equal to 0. It satisfies continuity equation, and hence it is an incompressible fluid. So flow is also steady and fluid is incompressible. We also have the rotation component for two-dimensional flow. So omega z is half into dou v by dou x minus dou u by dou y. Now take v, differentiate with respect to x. Take u, differentiate with respect to y, and put it in this equation. If you get 0, the rotation component is 0, then the flow is irrotational. Now taking v and differentiating with respect to x, again you can find that minus 2y is a constant. So numerator is a function of x and denominator is also a function of x. So therefore when you take dou v by dou x, so minus 2y is taken out, denominator, differentiation of numerator, so this differentiation of x is 1, minus numerator, that is x, differentiation of denominator is 2 times x square plus y square, 2, differentiation of x square is 2x by denominator square. Simplifying this, so we get x square, so take out x square plus y square, x square plus y square and x square plus y square here, it will become x square plus y square cube here. So now what you are left with, x square plus y square, and here it is minus. Okay, so this x square plus y square is gone, so it is minus 4x square. So that gives y square minus 3x square. So that is what is written. Okay, so this is about dou v by dou x. Now taking dou u by so finally you can write it as minus 2y cube plus 6x square y divided by x square plus y square cube. Now you take u, differentiate with respect to y. So taking u, differentiate with respect to y. Again it is the same thing. Numerator is a function of y, whereas denominator is also a function of y. So taking that, so a denominator differentiation of numerator, so y square differentiation is 2y minus numerator differentiation of denominator. So like this. So differentiation of y square is 2y. So here, so taking out x square plus y square, x square plus y square, and x square plus y square. So we are left with these terms. So now we have x square plus y square into 2y. So this x square plus y square gone. So y square minus x square is written here. So 2 into 2 is 4, so minus 4y. So simplifying this, we can write it as 2x square y plus 2y cube minus 4y cube plus 4x square y. So that gives, so minus 2y cube plus 6x square y. So now you can put it in omega z, that is half dou v by dou x minus dou u by dou y. So now you can find that. So minus 2y cube will cancel with plus 2y cube. 6x square y will cancel with minus 6x square y. So therefore omega z is 0. Since the rotation component is 0, the flow is irrotational. So this is how you solve for proving that the flow is incompressible or flow is possible. Then you satisfy continuity equation. If you want to say that it is an irrotational flow, then the rotation component omega z will be equal to 0. But if it was a three-dimensional flow, then all the three components have to be satisfied. That is, omega x should be 0, omega y should be 0, and omega z should be equal to 0. But since it was a two-dimensional flow, only omega z can be equal to 0. Now this is also a very important problem where we have the velocity components which are given by u is equal to y cube by 3 plus 2x minus x square y, and v is xy square minus 2y minus x cube by 3. We have to show that it is a possible case of fluid flow, or whether the flow is rotational or irrotational. Now to show that it is a possible case of fluid flow, since it is a two-dimensional flow, so therefore dou u by dou x plus dou v by dou y should be equal to 0. In order to show that flow is rotational or irrotational, so suppose omega z will be equal to 0, then flow is irrotational. If it is not equal to 0, then flow is rotational. Very simple problem. So therefore we have dou u by dou x. Here dou u by, so this will be 0, and differentiation of 2x is 2, and whereas differentiation of x square is 2x, so it will be minus 2xy. So similarly take v and differentiate with respect to y. Differentiation of y square is 2y, differentiation of y is 1. So similarly we get dou v by dou y as x into 2y minus 2. So therefore here it will be dou u by dou x plus dou v by dou y is 2 minus 2x plus 2xy minus 2, so which will cancel out and will be 0. Since the continuity equation is satisfied, so therefore it is a possible case of a fluid flow. Now to prove that omega z whether it is 0 or not, we have an equation for omega z which is half dou v by dou x minus dou u by dou y. So take v and differentiate with respect to x. So when you take differentiate with respect to x, differentiation of x is 1, so it remains as y square. So this will be 0. So here it will be minus 3x square divided by 3, so it is minus x square. So therefore here we have differentiation of v with respect to x is y square. Similarly this will be 0, and here it will be minus 3x square by 3. So similarly minus dou u by dou y, so it is 3y square by 3. This differentiation will be 0, so differentiation of this will be minus x square. So simply simplifying this, 3 and 3 cancels out, so y square minus x square minus y square plus x square. So if you just put in this equation, it will be 0. Since the rotation component is 0, so therefore flow is irrotational. So here the velocity vector is given as y square plus z square into I is the unit vector, and plus x square plus z square j plus x square plus y square k. Find at the point 1, 2, 3 the components of the acceleration and components of rotation. So given the velocity vector, so here it is nothing but v is equal to ui plus vj plus wk. So therefore, the component of velocity, first we should identify the components of velocity. So u is y square plus z square, v is x square plus z square, and w is x square plus y square. So that is what you should first write. Then you take up the equations for the components of acceleration, that is ax, ay, and az. You know that ax is nothing but u dou u by dou x plus v dou u by dou y plus w dou u by dou z. So now take u, substitute here, which is y square plus z square, and this is dou u by dou x. So here there is no x term, so it will be 0. Similarly, take v, which is x square plus z square, differentiate u with respect to y, it will be 2y. Take w, substitute as x square plus y square, and differentiate u with respect to z, which will be 2z. So this is what you should do. Now substitute the value of x is equal to 1, y is equal to 2, and z is equal to 3. So after substitution, so you get something like 70 units, which can be meter per second square. Similarly, you can write an expression for ay, acceleration in y direction, which will be u dou v by dou x plus v dou v by dou y plus w dou v by dou z. So now take u, substitute, take v, differentiate with respect to x, it will be 2x plus v, which is x square plus z square, differentiate v with respect to y, it will be 0. Take w, x square plus y square, again take v, differentiate with respect to z, so differentiation with respect to z is 2z. So substitute. So you have now substitute the value of x is equal to 1, y is equal to 2, and z is equal to 3. So you get something like 56 units, which units can be meter per second square. Similarly, acceleration, the z direction will be u into dou w by dou x plus v dou w by dou y plus w dou w dou z. So that gives, so take u and substitute, which is y square plus z square. Take w and differentiate with respect to x, so you will get 2x. Substitute the value of v as x square plus y square. Take w, okay, take w and differentiate with respect to y, which was x square plus y square. Differentiation of y square is 2y, so written here. So take w is x square plus y square and differentiate with respect to z. So there is no z term, so it will be 0. Substitute the values of x, y, z. So you will get as 66 units, which is meter per second square. Similarly, the total acceleration is root of ax square plus ay square plus az square can also be determined. The components of rotations are, so that is, first you can write an equation for omega z, which is half into dou v by dou x minus dou u by dou y. So this is, so you have to take v and differentiate with respect to x, take u, differentiate with respect to y, so which gives here, so you know that v is x square plus z square. When you differentiate, it will be 2x. Take u, which is y square plus z square, differentiate with respect to y, which is 2y. So it is 2x minus 2y, which can be x minus y. So all substitute the values of x and y, so it will be minus 1. Similarly, you can take omega x in cyclic order, you can start writing. So half dou w by dou y minus dou v by dou z. So we take w and differentiate with respect to y, it will be 2y. Take v and differentiate with respect to z, so which will be 2z. So that gives, again put the value, so you will get minus 1 as the answer. Write wy in a cyclic order, which is half dou u by dou z minus dou w by dou x. Take u and differentiate with respect to z, which will be 2z. Take w and differentiate with respect to x, which will be 2x. So that gives half into 2z minus 2x. Substituting the value, so you will get 2 as the answer. So these are the components of the rotations, which can be determined by using the equations that were there for the rotation components like omega x, omega y, and z. Again, similar problems which is related to v. So velocity vector will be given. So now you know that 4x cube is u, minus 10x square y is v, and 2t will be w. So you have to find the velocity and accelerations at point 2, 1, 3, and also that is at time, since time is involved here, so time is given as 1 seconds. So this is what you should write. So now you know the velocity, so you can find out the velocity components by substituting the values of x, y and z, or the t value. Okay, so wherever is there, you can find out the velocity components by writing as u 32 units, so the 4 into 2 cube. Unit can be meter per second. Velocity is if we substitute in minus 10x square y, so like x and y, so we'll get minus 40 units, and w is 2 units because time is 1 second. So therefore you can find out the velocity vector. So that is magnitude of the velocity is the root of u square plus v square plus w square, so which gives so much units. So 51.26 units, which is can be meter per second. Similarly, acceleration, you know that the acceleration components can always determine. So these components of acceleration already I had discussed in the previous problem. So now you can do that. So that is acceleration u dou u by dou x plus v dou u by dou y plus w dou u by dou z. Take u and differentiate. So u already you know the answer, that is 32 units. So dou u by dou x is that u is 4x cube, so it will be 4 into 3x square. Similarly, there is no y term, so dou u by dou y is 0. There is no z term, so it is 0. So therefore, substituting the value of x, you will get 128 units, which can be meter per second square. Similarly, you can find out acceleration in the y directions. Again, u is known, which is 32 units, v is known as 40 units, minus 40, and w is 2 units. Similarly, by knowing the equation for v, you can always differentiate with respect to x, differentiate with respect to y, and differentiate with respect to z, and substitute here. So after substituting the values of x and y, you will get 320 units. Similarly, you can take az, which is u dou w by dou x plus v dou w by dou y plus w into dou w by dou z. Take the equation for w, which was 2t, so there is no x term, so 0, no y term, so 0, no w, that is no z term, so it will be 0. So therefore acceleration in the z direction will be 0. So now the total acceleration can be determined as root of ax square plus ay square plus az square, which comes to 344.65 units, which can be meter per second square. Okay. So now comes a few problems on stream functions as well as on the velocity potentials. We already had the definitions of stream functions and the velocity potential functions. Velocity potential function is a function of space and time such that its negative derivative with respect to any direction gives the velocity component in the same direction. So therefore, that minus dou phi by dou x is u, minus dou phi by dou y is v, minus dou phi by dou z is w. Similarly, stream function is a function of space and time such that the partial derivative with respect to any direction gives velocity component at right angles to the direction. So if psi is a function of x and y, so dou psi by dou x is minus u, whereas dou psi by dou y is dou psi by, that's what, if you differentiate with respect to x, that is my dou psi by dou x, we got it as v, dou psi by dou y as minus u. So the right angles we will get. So these definitions should be used in this. When in order to show that flow is rotational, if psi is given, so we said that we have to satisfy Laplace equation. So dou square phi by dou x square plus dou square and dou square psi by dou x square plus dou square psi by dou y square has to be equal to 0. So that can be done. So when psi is given to xy, instead of say going ahead with omega z is equal to 0, we can always go ahead with Laplace equation if psi and phi are given. So here differentiate with respect to x, it will be 2y, so there is no x term, so next differentiation will be 0. Again, dou psi by dou y is 2x. Again, one more differentiation will give 0. So dou square psi by dou x square plus dou square psi by dou y square has to be 0. Since the given function psi satisfies Laplace equation, the flow is irrotational. Now coming to determining the velocity potential function, so we can make use of the definition of velocity potential function. So here it is given as psi is equal to 2xy. So but we'll make use of the definition of stream function. So that is, by definition of stream function, we have dou psi by dou x, that is component in the right angles, that is v. So therefore take psi and differentiate with respect to dou psi by dou x is v, so therefore we have v as 2y. Okay, so that means you can take psi and differentiate with respect to x, so therefore we'll get the component of velocity, that is v is equal to 2y. So now another definition is dou psi by dou y is minus u, so therefore you take psi and differentiate with respect to y, you will get to 2x, so u will be minus 2x. So now we know the definitions of velocity potential functions. So negative derivative of phi with respect to x is u. So therefore dou phi by dou x will be minus u. So minus of minus 2x will be plus 2x. So dou phi by dou x is 2x. Now you integrate this with respect to x. When you integrate this with respect to x, so you will get 2 x square by 2 plus function of y. So 2 and 2 cancels out, so therefore it will be x square plus function of y. So this is one equation. So now we can use the another definition of velocity potential. So negative derivative of phi with respect to y is v. So you can dou phi by dou y is minus v, but v is given, which is 2y, so it will be minus 2y. So you integrate this with respect to y, so you will get another answer, that's phi, which is minus 2. So integration of y is y square by 2 plus function of x. So if you combine these two equations, combining equation 1 from previous this definition, and by this definition you get one more. So when you try to combine these two answers, so you will get phi is equal to x square minus y square plus some constant, which constant of integration, which can be taken as 0. So therefore the velocity potential function is given by x square minus y square. So this is how, given the stream function, you can find out velocity potential, or if it is given the velocity potential, you can always find out the stream function. So this problem is very important, where stream function psi is given by psi is equal to tan inverse of y by x. Check whether the flow is rotational. So to checking this, again you should satisfy Laplace equation, dou square psi by dou x square plus dou square psi by dou y square should be equal to 0. So you can use the definition of psi and find out the velocity and substitute the value of x and y. So now we will go for dou psi by dou x, which is, you know that differentiation of tan inverse is 1 by 1 plus y by x whole square, and differentiation of y by x, so y is a constant, so differentiation of 1 by x is minus 1 by x square. So that gives where you can take, here you can take the LCM, so therefore x square, the LCM is x square, so x square plus y square, and the x square will go to the numerator. So this x square and x square cancels out, you are left with minus y by x square plus y square. So similarly, one more differentiation will give you here, so minus y is a constant, so denominator, differentiation of numerator, so again with one differentiation 0, so minus 1 differentiation of denominator is 2x by denominator square, so you get 2xy by x square plus y square whole square. Now take psi and differentiate with respect to y, so here is 1 by 1 plus y square by x square, 1 by x is a constant, differentiation of y is 1. So that gives x square by x square plus y square by 1 by x. So that gives x by x square plus y square. So one more differentiation with respect to y. So we'll give you x is a constant, denominator, differentiation of numerator is 0, minus 1, differentiation of denominator is 2y by denominator square. So that gives minus 2xy by x square plus y square whole square. So if you add these two, so you will get that dou square psi by dou x square plus dou square psi by dou y square is equal to 0. So therefore, since it satisfies Laplace equation, the flow is irrotational. Now to find out the components, so we'll use the definition of stream function. So we know that dou psi by dou x is v. So now you differentiate tan inverse of y by x with respect to x. So that gives 1 by 1 plus y square by x square. Differentiation of 1 by x is minus 1 by x square. So that gives minus y by x square. So that is v. So you substitute the values of so which will give minus y by x square plus y square. Substitute so that you will get v as x as 2 and y is 6. So you will get minus 6 by 40. That is meter per second, or minus 0.15 meter per second. Now take another definition of stream function. Dou psi by dou y is minus u. So now take psi and differentiate with respect to y. So we have, so differentiation of tan inverse of y by x is minus 1 by 1 plus y square by x square. So minus this minus is written here, and differentiation of y is 1. So this again simplifying, we'll get like this, minus x by x square plus y square. Substitute the value of x as 2 and y is equal to 6. So therefore u will be 0.05 meter per second square. So therefore the velocity vector is root of u square plus v square, which will give 0.158 meter per second. So this is how you find the components of the velocity u and v, and also the magnitude of the resultant velocity. So given the velocity potential phi is what, the last time the last previous two problem I did that, given the value of psi, and I determined the velocity potential function. Now I have given the velocity potential, but you have to find out the velocity components making use of the definition, and also you have to show the flow is rotational. Again, dou square phi by dou x square plus dou square phi by dou y square has to be equal to 0, and next use the definitions and find out the stream function psi. So now getting like the definition, and so negative derivative of phi with respect to x is u, negative derivative of phi with respect to y is v. So now that can be determined. So therefore u has to be, so minus of dou phi by dou x, so that is minus 5. Differentiation of x square is 2x, so that gives minus 10x. Similarly, we have v, which is minus 5 into differentiation of minus y square is minus 2y. So that's how we can find out the components of velocity, that is u and v. Substitute the values of x. So you will get x is 4 and y is 5. So you get u as minus 40 units and v is 50 units. Next is to show that flow is irrotational. So you can differentiate with respect to, so dou phi by dou x with respect to x, phi into 2x. One more differentiation will give me like dou phi by dou x is 5 into 2x. Similarly, dou phi by dou y is 5 into minus 2y. So next differentiation, dou square phi by dou x square is 10. Here dou square phi by dou x square is minus 10. So now Laplace equation is dou square phi by dou x square plus dou square phi by dou y square is 10 minus 10, which is equal to 0. And since the given function phi satisfies Laplace equation, the flow is irrotational. To return the stream function psi, now we make use of the definition dou psi by dou x is v. So we know that here, so okay, so dou psi by taking the function psi, you can differentiate so that we get so here dou psi by dou x is v. We already determined the value of v from velocity potential, so that is known as 10, and that is given as 10y, which we already determined. So I substitute the value of v. So now integrating here, and you will get psi, which is 10 integration of 10y, in the integration of 1 is x, so it will be 10xy. Now take another definition, that is dou psi by dou y is minus u, but already we know the value of u, which is okay, so minus of minus 10x, so that gives 10x. Integrate this with respect to y, so that you get psi as 10xy. Since both the terms are same, so it is not like 10xy plus 10xy is 20xy. So while combining that, we have to take the similar terms, we should write it once, all other terms we should write it again once. So therefore it's not that it is combining, means it is not adding, it is picking out the similar terms and also writing the other terms if there are there. So therefore psi has to be only 10xy. So therefore the stream function value is 10xy. So here you given again very interesting problem. So already I had solved for u is equal to y cube by 3 plus 2x minus x square y plus b, and that is v is xy square minus 2y minus x cube by 3. I already proved that here that it satisfies continuity equation, and here I am going ahead and finding out that show that the flow is rotational. So here since u and v is already given, so it is best is to that instead of going for Laplace equations, we have to prove that omega z is equal to 0. So here omega z is half, that is into dou v by dou x minus dou u by dou y. So we can always find out dou v by dou x. So dou v by dou x here is so y square minus that is 3x square by 3, and dou u by dou y is minus the minus into say dou u by dou y. So dou u by dou y is 3y square by 3, and again 2x is 0, so minus x square y is minus x square. So when you simplify this is y square minus x square minus y square plus x square. So here it gets cancelled out, so it will be 0. Since omega z is 0, flow is rotational. Now we'll go ahead with finding the stream function value, the psi. So by definition you know that dou psi by dou x is v. Okay, so here and here the v value is given. So v is xy square minus 2y minus x cube by 3. Now you integrate this with respect to x. So when you integrate this, we get integration of x is x square by 2 minus 2y, integration of 1 is x, so it is minus 2xy, integration of x cube is x4 to the by 4 into 3 is 12. So we get equation 1. So take another definition, dou psi by dou y is minus u. So when you write this, you have already the velocity component, so you substitute the velocity components here. So that is this. So now you integrate this with respect to y. So when you integrate this with respect to y, it will be minus y4 by 12 minus 2xy plus x square, integration of y is y square by 2. So now see this expression and this expression. So by combining, so you can find that x square plus, that's what I said in the previous problem, x square plus y square by 2 and x square plus y square by 2 is one common term. Minus 2xy and minus 2xy is one common. So this is a different term, this is a different term. So these two I'll be writing as ones, these two I'll be writing as ones. So when you're combining this, that the function can be written as x square plus y square by 2 only once, minus 2xy is once, so then minus x to the power of 4 by 12 and minus y to the power of 12. So this is how you write the equations when you are trying to combine equation 1 and equation 2. So last time 10xy plus 10x I didn't write as 20xy, I wrote it as 10xy only. So this is what is to show that problem, that we write the similar terms once and other terms again once. Now coming to the velocity potential, we know that negative derivative of phi with respect to x is u. Substitute the value of u. So therefore dou phi by dou x you will get, integrate this with respect to x. When you integrate that, we get integration with respect to x is minus xy cube. Here integration of x is x square by 2, then integration of x square is x cube by 3. So we get here the function phi as equation 1. Take another definition, minus dou phi by dou y is v. Substitute the value of v. So we get dou phi by dou y is minus v, so that minus xy square plus 2y plus x cube by 3. Now you integrate this with respect to y. So when you integrate with respect to y, it is y square, integration is y cube by 3, integration of y is y square by 2, integration here is integration of 1, which is y. So now you can again combine 1 and 2. So what happens is that minus xy cube by 3 is one common term, x cube y by 3 is again a common term, minus x square and plus y square. So therefore it will be like phi equals minus xy cube by 3 written once, x cube y by 3 written once, then what remains, minus x square remains, so we wrote this here, and also plus y square remains y square. So this is the